In our everyday, we usually measure angles in degrees. In mathematics and engineering, however, radians are much more commonly used. They're defined in terms of the arc of a circle. And a radian is the angle made when we take the radius and wrap it around the edge of the circle. This is tough to show in words, but this YouTube clip gives you a perfect animation of what this looks like. We got any circle of any size. To create 1 radian, we simply take the measure of the radius, the length of the radius, and wrap it around the circumference of the circle. At the point where we run out of radius, we're going to go straight back to the center of a circle. Because the radian is defined by a ratio, it's technically unitless. But even though it's unitless, for clear communication, we often indicate that a measure is in radians by indicating that it is in rad. How are radians and degrees related? Turns out that if we go 180 degrees, we've traveled a little over 3 radians, or approximately 3.14 radians. Exactly how far have we gone? We've traveled pi radians in 180 degrees. So if we travel another pi radians to get to 360 degrees, or all the way around the circle, we've traveled approximately 6.28 radians, or exactly 2 pi radians. So for every 2 pi radians, we travel 360 degrees, or put another way, pi radians is equal to 180 degrees. Because the second one is a little bit simpler, it's usually the one that we use when we're writing conversion factors. Since pi radians is equal to 180 degrees, pi radians divided by 180 degrees is equal to 180 degrees divided by pi radians, and both of these are equal to 1. So we can use either of these fractions, of these ratios, as a conversion factor. Let's see how that's done. What is 85 degrees in radians? Okay, so we're starting with 85 degrees, and we want to convert this to radians. If we remember our conversion factors from the previous slide, we know that 180 degrees is equal to pi radians, and therefore pi radians is equal to 180 degrees, and so both of these conversion factors have a value of 1, so they won't change the value of our angle. We want to change this from degrees to radians, so we want to multiply by the second conversion factor, so that degrees in the numerator cancel with degrees in the denominator. So we have pi radians over 180 degrees. Degrees cancel, and we end up with 85 times pi divided by 180 radians. We commonly write radians as reduced fractions containing pi rather than as decimals, and that's what's asked for here. So we want to simplify 85 over 180 if possible and leave pi as a part of the answer. Turns out both 85 and 180 are divisible by 5, and here we get 17 pi over 36 radians. Start. What about going the other way? 5 pi over 6 is a measure in radians. We want to convert that to degrees, and since radians is currently the unit in the numerator, we want to use the conversion factor that has the unit in the denominator. 180 degrees is equal to pi radians. This is nice and tidy because not only does radians cancel, but the pi cancels as well. So we don't have to worry about it in our final answer. If we multiply these two fractions, we get 5 times 180 degrees divided by 6. 5 times 180 degrees divided by 6, or 5/6 of 180 degrees, is 150, and our units are still in degrees. Here they are. And finally, I'm going to change this question a little bit on us. We want to take start. And finally, I'm going to change this question a little bit. We want to take 1.5 radians and convert that to degrees. So similarly to the previous question, we're going to multiply by 180 degrees divided by pi radians. But this time only radians cancels, and we're left with pi in the denominator. So we have 1.8 times 180 degrees divided by pi left over. This time we do need to reach for our calculators. I recommend that rather than substituting pi with 3.14, that you use the pi button on your calculator. So type in 1.5, multiply that by 180, and divide the result by pi using the pi button. We should get 85.9 degrees, a little less than 90 degrees. And finally, how do we use radians in trigonometric functions? This first question asks us to take the sine of 10 degrees. Very clearly stated that the units here are degrees. This is what we've been doing all along. So we punch sine 10 into our calculators, making sure that your calculator is in degree mode. So you should have a little D somewhere on your display. You'll find that the sine of 10 degrees is 0.174. For the next question, I haven't forgotten the degree symbol. This means that it's in the unit of radians. Make sure that your calculator is in radian mode. You have to tell your calculator that this value is in a different unit of measure than the one we've been using, specifically that it's in radians. Once your calculator is in radians, it's expecting that 10 to be a measure in radians, and the sine of 10 is negative 0.544. Finally here, the sine of 5 pi over 6. Once again, radians is a measure that is a ratio. So it's okay to write 5 pi over 6 or 10 like this without the degree symbol. It simply means, once again, that we are in the units of radians, and we need to tell our calculator to expect our angle to be in that measure. We find that the sine of 5 pi over 6 is 0.5. So when you're evaluating trigonometric functions, either to find the ratio as we did here, or taking the inverse sine, cosine, or tangent to find the angle, make sure that your calculator is in the correct units.